Hello. Today I'm going to go over more how to use substitution to solve a system of equations. Now, I want you to watch this and make sure you're paying attention if you're still having trouble with either the worksheet or 2.1 practice, or you're getting ready for a quiz and you need a review. So it's going to be one problem, and I'm going to try to do it the most inconvenient, or not the most inconvenient way possible, but a pretty not straightforward way, so that if you get to the point in a problem where it's not super duper easy, we can deal with that. So here's our system. And we need to do step by step by step. So step 1 says choose one equation to solve for x, y, or z. That's exactly what it says, so that's exactly what we're going to do. Now, if you look, we have a couple of easy variables. And when I say easy, I mean no number out front. So I would say that these are easy variables. Now, most of the time we end up solving for x, and I want to get you out of that habit because that might not be the easiest variable to solve for. So I'm going to take that first equation, x minus y equals 5, and I'm going to solve for y. Now when I solve for y, I need to get y by itself, so I'm going to subtract the x. So that negative y equals 5 minus x. Now here's where people mess up, because they forget that we don't actually care about what negative y is. We want to know what y is. So we need to divide by negative 1, which makes y negative 5 plus x. Okay, because whenever you divide by a negative 1, you're changing your signs. Now, let's go to step 2. Substitute the expression for the chosen variable in the other two equations and simplify. So we used equation 1, that means that we have to plug it into equation 2. So we have negative x plus 4 times our y, which is negative 5 plus x. Then plus 2z, and that'll give us 3. So we distribute negative x minus 20 plus 4x plus 2z equals 3. Now remember, when it says to simplify, we actually want to make sure that we get all of our variables on one side and our numbers on the other. So we need to combine like terms and move the constants to the other side. So we have a negative x on a positive 4x. Well, I didn't touch the negative 20, so I'm going to write negative 20 again. 4 minus 1 is 3x's plus 2z equals 3. Now the last thing I need to do here is make sure that 20 is on the other side, so we're going to add 20. So 3x plus 2z equals 23. Now I'm going to plug into the other equation. I did the second one, now I need to plug into the third one. So we have negative x plus 3y minus 5z equals negative 6. But instead of a y, we actually needed negative x plus 3 times negative 5 plus x minus 5z equals negative 6. We distribute, so that negative x, minus 15 plus 3x minus 5z equals negative 6. Then again, we need to combine our like terms. We have a negative x and a positive 3x. We didn't touch the negative 15, so we write it again. Plus 2x minus 5z equals negative 6. Add 15 to both sides, because we want those constants on that side. So that 2x minus 5z equals 9. And there we have it. We have the blue equation and the red equation. And we need to pick one to solve for variable. Now, none of these look very nice. And that happens a lot. And when that happens, you just kind of pick one and go with it. So let's pick that second equation, just because we can. 2x minus 5z equals 9. And we need to solve for a variable. It doesn't matter which one, as long as you get it by itself. So I'm going to go ahead and solve for x. So add 5z. So that 2x equals 9 plus 5z. Divide by 2. right? Because you have to get rid of that 2. I don't care what 2x is. I want to know what x is. And now whenever we write these as fractions, I'm going to go ahead and split them up just in case. Then later on, I don't have to worry about it then. So 9 over 2 plus 5 over 2z. Now step 4 says to substitute this expression, so the x equals expression, for the selected variable into the remaining equation and solve. Well, when it says the remaining equation, it's talking about your equations from step 2, and the one that we did not use was the blue one. So we are going to write that blue equation right here. In our step 4 box, we have 3x plus 2z equals 23. And we're going to replace x with what we just found for x. So we have 3 times 9 over 2 plus 5 over 2z plus 2z equals 23. Now we need to distribute. And when we distribute, those fractions are not going to go away. Not this time. And that's okay. It'll all get better eventually. But for now, we have 9 times 3 is 27 over 2. 3 times 5 is 15 over 2z. Plus 2z equals 23. Now we still need to combine like terms. So we need to combine the 15 over 2z and the 2z. That will give you 19 over 2. If you don't believe me, use your calculator. So we need to get the z by itself, which means that we actually need to subtract the 27 over 2 because it's still being added, even though it's a fraction. It's okay. So those cancel. We end up with 19 over 2z equals 19 over 2. And this is where it gets nice again, because anytime you divide, right, because we're going to need to divide by the coefficient to find z. Anytime you divide by the same number, you get 1. So that went away very nicely. Okay, and it should go away very nicely. So all is well with the world again. And now we take that z and we're plugging it into the red equation. Because we know that x equals 9 over 2 plus 5 over 2z. Well, since we know what z is, we know that z equals 1, we can plug that in. So we have 9 over 2 plus 5 over 2 times 1. Well, 9 over 2 plus 5 over 2 is 14 over 2, which gives us 7. So x equals 7. The last thing we need to find still is y. And the reason we still have to find y is because we solved for that all the way back in step 1. And in step 1, we found out that y equals negative 5 plus x. Well, we actually know what x is now. Well, x is 7, so y equals negative 5 plus 7, which is 2. So y equals 2. We have x, we have y, we have z. Let's put them in order. 7, 2, 1. Final answer. If you need any help, make sure you're coming in for tutoring. Make sure you're coming in for tutoring. That's what I'm here for. Okay, have a nice day.